Hey, welcome to GeoSolve. This is an interesting and a little bit challenging Olympiad question. Both ABCDE and PQRST are regular pentagons, and we are asked the ratio of their areas. First of all, we should know that these two pentagons are similar, and so their areas must be proportional to the square of their sides. We also should know that all the internal angles of a regular pentagon is 108 degrees. From here, we can calculate these angles as 36 degrees using the ABE isosceles triangle. Similarly, using ABC and AED isosceles triangles, these angles will be also 36 degrees. And from here, these angles can be calculated easily using exterior angle theorem. Now let's focus on the ratio we are looking for again. We can write this ratio also like this by multiplying both the numerator and denominator by AP. And let's call this equation 1. Now let's apply sine theorem on triangle ABQ. We can write AB over sine 72 equals AQ over sine 36. Rearranging the terms, we can write the equation like this. And since AQ equals AP, we can write AP instead of AQ. Now let's apply sine theorem on this triangle. From here, we can write AP over sine 72 equals PQ over sine 36. Rearranging the terms, we can write the equation like this. Now inserting the known values into equation 1, we can write our ratio as follows. And that can be written as sine square 72 over sine square 36. Let's make some space and continue from here. Now we can use the relationship sine 2x equals 2 times sine x times cosine x to expand our expression. Then let's take the square of all the terms in the parentheses. Sine square 36 terms will cancel, and our expression will be 4 times cosine square 36. And don't forget that we are looking for the square of this ratio to find the area ratio. Now we need to find the value of cosine 36. At this point, you can use a scientific calculator to find the value of cosine 36 and go from there to answer to the question. But we don't want that. We want the exact answer by hand. Now let's assume an x equals 18 degrees. Then 5x will be equal to 90 degrees. And let's write that expression as 2x plus 3x equals 90. And let's rearrange the terms like this. Now take sine of both sides and we will have the following expression. Recall that sine 90 minus a can be written as cosine a. Applying this to our expression, we will have sine 2x equals cosine 3x. Also recall that sine 2a is equal to 2 times sine a times cosine a. Let's apply that to our expression. And remember that cosine 3a can be written as 4 times cosine cube a minus 3 times cosine a. Let's apply that to our expression also. Now let's simplify our expression by dividing both sides by cosine x. Here recall that cosine square a can be written as 1 minus sine square a. Applying this to our expression, we will have the following. Now let's distribute 4 over the square brackets. Rearranging the terms, we will have this final equation. Now we can solve this quadratic equation using quadratic formula. Simplifying the expression, sin x will be equal to minus 1 plus minus square root of 5 over 4. Since we called x equals 18 degrees earlier, we can write sin 18 instead of sin x. And also we know that sin 18 should be positive. So we will take the positive root. Now we have the value of sin 18. We can continue our journey to find cosine 36. We can write cosine 36 as cosine 2 times 18. And using the cosine 2a relationship, we can write something like this. And that will simplify to 1 plus square root of 5 over 4. Now returning our original question, first we need to find this value. Plugging in the cosine 36 value, we have this expression. Simplifying the expression, we will have AB over PQ ratio as 3 plus square root of 5 over 2. And as we showed previously, our area ratio will be the square of AB over PQ. Taking the square of AB over PQ, we will have 7 plus 3 times square root of 5 all over 2. And that will be our answer. I hope you enjoyed this one. I'll see you next time.